Hey everybody, welcome back for another week of contemporary math. Just a quick notice, there is some construction going on around my house, and sometimes they're using my driveway and they're yelling at each other. So in case you hear, construction sounds or people yelling at each other in a different language, that's what's going on. But I have to make these videos, so yeah, we're just gonna have to deal with it. Anyway, today we are going to start talking about counting. This whole week is going to be about counting. Last week we talked about probability, figuring out how likely something is to happen. So this week we're going to be doing counting, and then the next week we'll be combining counting and probability. So the first thing we're going to talk about with counting is this fundamental counting principle. So it's kind of a long definition. Let me zoom in a little bit. I'm going to go ahead and read it. So for a sequence of n experiments, where the first experiment has k sub 1 outcomes, the second experiment has k sub 2 outcomes, the third experiment has k sub 3 outcomes, and so forth, the total number of possible outcomes for this sequence of experiments is, and they just multiply these numbers together. K sub 1 times K sub 2 times K sub 3, and then if there's more, you just keep multiplying. So that might look a little crazy because it's a mathematical definition. Basically what we're saying is if you're doing an experiment and one thing can happen in so many ways, the second thing can happen in so many ways, the third thing can happen in so many ways, we just multiply the number of ways each thing can happen. I don't know if that quite made sense, but we will look at some examples and hopefully that it'll start to click. Before we do those examples, two quick just notes, I guess. So often we will use these terms of with replacement or without replacement. And with replacement means when we're counting possible outcomes with replacement, objects are placed back into consideration for the next choice. And then without replacement, that means those objects are not placed back into consideration. So for example, if we just think about a deck of cards, if we're trying to kind of to tie it into probability, if we're going to pick out, say you're going to pick out two cards, well, if it's with replacement, you would pick out the first card, put it back, and then pick out another card. That's with replacement. So you're still working with the entire sample space that you started with. Without replacement, if you're, taking two cards from a deck, you take that first card, you keep it, and then you take that second card. So again, we'll apply this to these examples. So if that doesn't quite make sense, it'll make sense in just a moment. So let's get started. Example number 1. A company puts a code on each different product they sell. The code is made up of 3 numbers and 2 letters. How many different codes are possible if repetition is allowed? That is, with replacement. So another way we can say with replacement is repetition is allowed. All right, so how can we figure this out? It's going to be a lot. There's going to be a lot of different codes, right? But what's the exact number? So I like to kind of draw a picture when I do these problems. And so I'm going to try and write it on this actual page. So it's a code of 3 numbers and 2 letters. So there's going to be 5 characters, I guess you could say. So I'm going to draw a line, 1, 2, 3, 4, and 5, right? There's 5 characters in this code, 3 numbers and 2 letters. So let's suppose we kind of just go in order, that they have the 3 numbers first and then they follow up with the 2 letters. All right, so the 3 numbers. So when we talk about picking out a number, we're talking about a single digit. So when we pick out these 3 numbers, it could be any number from 0 to 9. Now, if you actually count out 0 to 9, there's 10 digits there. 10 numbers, 10 digits, however you want to look at it. I know that, like, and if you check me, right? Count from 0 is 1, and then all the way out to 9, there's actually 10 different digits, not 9. So for this first code, like the first character in this code, there's 10 possible digits we can pick from, right? From 0 to 9. All right. So I drew this little symbol here because we're going to be multiplying these numbers. That's what the fundamental counting principle says. We are going to multiply all these numbers that we find, but we got to finish finding them. So the next keyword thing, the next key word here is repetition, right? Repetition is allowed. So I could pick the same number 3 times. So for this second option, we still have 10 digits to choose from, right? From 0 to 9. For this third option, once again, we have 10 digits to work from because we can repeat digits if we want. Okay, so that makes up our 3 numbers. Got that. Now we can also have 2 letters. All right, so this is something you just want to know. We're going to be using this a lot. So from 0 to 9, that's 10 digits. You want to memorize that. And from A to Z, there are 26 letters. There's 26 letters in our alphabet. So if this is a letter, how many choices do we have? How many letters do we have to pick from? Well, 26. That's all we have in the alphabet. And then repetition is allowed. So we have another 26 that we can pick from. Okay. So these are all we wrote out the different options, or the number of options we have for each character in this code, right? We have 10 different numbers to pick from for the first character, 10 numbers to pick from for the second, 10 for the third, and then when we start picking our letters, there's 26 letters in the alphabet, so we have 26 choices for each of these. So the fundamental counting principle says the total number of ways the total number of different codes we can have, we just multiply these numbers together. So pop that into your calculator, and we get 676,000. So there are 676,000 different codes. So quick note before we go to the next problem. I started with the 3 numbers, and then I did the 2 letters. Really, the code could be all mixed up, right? It could be a letter, a number, a letter, and then 2 numbers. And remember, if it's a letter, there's 26 choices. If it's a number, there's 10 choices. A letter is 26 choices. A number is 10 choices. No matter what, if you multiply these numbers together, we're gonna get the same exact value. So you don't have to worry right now about the order. The whole point is just multiplying all the numbers together. Okay.